These are going to be the table legs for the big steel table that I'm building for the shop here. And what I want to do on all 6 of them, I've got 6 legs, is just machine one end square so that it sits nice and square on the table with just make it a little bit easier anyway, just because I can. And another cool job for the shaper right here. So they're 4-inch square tubing, so we've got 3 of them stacked in. That's going to be a 12-inch long cut right there. We're going to make use of the automatic down feed on the tool head there. Nice feature that the shaper has. Just a real simple operation, nothing much to it. Just having a little fun with the machine. These were pretty rusty. I've still got to wire brush the other 3, and I just cleaned them off with the wire wheel outside. And I've got some CRC rust converter ordered, and I seen some guys using it on some other YouTube channels. It seems like it works pretty good, so I'm going to try it for these table legs. Supposed to convert the rust into a primed surface that you can paint, or probably just leave it just like that. Turns it black. So that's it. Let's go ahead and get started on it. This is the tool we're going to be using. Just honed in that corner radius. We got some back rake, and we got some side rake there. Let's see how that'll do. I got the machine set up on 76 feet per minute. We're running 28 strokes a minute with a 13-inch length of cut there. And we got everything set. I've actually touched off, and we've stepped it over 60 thousandths, so we're going to be moving 1/16 of an inch or 60 thousandths from the side. Actually it's 62, but there and about. And we're going to use a 20 thousandths down feed. We're ready to go. I've got everything set, so let's go. Beautiful cut. It's doing good. Making light work of that. So when we were doing this in the first video, I showed this new tool from Edge Technology. It's the chuck stop, and what I had learned by setting this up is that I'm not too fond of having to take these parallels off and switch them out every time. So I had suggested to Edge that what would be nice is if you could actually get a spider for each one of the parallels. So they supply the full set of parallels whenever you buy one of these. All right. And it would be nice to just have them all set up so that you save time on switching these things out. Okay, so they have sent me out 9 more of these spiders so that I will have a complete set of these parallels already set and ready to go. I don't have to take them on and off. And they actually liked the suggestion, so they're supposed to be making these chuck stop spiders available for purchase on their website separately from the whole kit. So anybody else that might be interested. The centering ring here on mine, that's a 3-inch bore, and I just take and file that. I think it's just the corners that was hitting, and I got a good fit now. So now that you have, now that I have an extra spider, so I can just pull one out. And by the way, it just got magnets there that hold it on. And just stick the other one in there. Get it centered. Pretty close on that centering ring. There it goes. Okay. So I wanted a little bit taller parallel so that the work pieces would actually stick out of the chuck a little bit more, because I want to turn 1 inch on this, and it was right up close to the jaw. So I'm going to go ahead and finish setting all these up, and I'm going to have them in my Equipto cabinet down there so that I can just grab them and go, and I don't have to reset them every time. I also found that it's best just to hold in on it whenever I was doing this job anyway, and not come in here and bump on it. Just push it in, tighten the chuck, and you should be good to go. Alright, so now we're going to get started turning. They're approximately 2 inches long. So what we'll do, since they're up against that parallel, I can just put my scale there, and I'm not worried about it being exactly 1 inch of depth, but we're going to do about half. I'm just lining up with my scale right there on that 1 inch line, and that's close enough. I'm going to set a 0 on my dial indicator right here, and I'm going to spin the chuck to make sure that it clears good, and we are ready to turn. Measuring the inside of the tube, it's getting approximately 3 inch 30 thousandths inside the walls. This is 3.5 inch stock right there, so we've got what, about 470 thousandths to come off of that right there. I may just make 5 even cuts on it. We'll see how the machine reacts. Alright, that's 100 thousandths. 12,000 feed rate. Alright, that should be, yep, that's going to put us there. So we got 50, 65 thousandths. Chip got in there and scratched it, but this is all going to be hidden. So 3 inch 30 thousandths. I'm going to go ahead and chamfer that, and let's go test it on the tube and see if it fits. Now I don't think I'll be able to use this one up on that shoulder. Let me come up here and look. Yeah, it's just too close. set up my Armstrong holder with it and pull that tool out a little bit. I'll get in there with this one and break that edge. That's what we want right there. Got just a little bit of wiggle room. Go ahead and check all of them, make sure that it'll fit. I could maybe give it another 10 thousandths on the diameter to tighten it up. That's a good fit right there. So that's the plan. That's our feet. That's the pad. And I'm going to weld these on, and then we're going to drill and tap it after I have them all turned. So I'm going to go ahead and finish turning all 6 of them just like this, and then we'll move on to the drilling and tapping. All right, it is time to get these things drilled and tapped. 3/4 tin for our machinery pads to screw into. We're going to make use of our 3-jaw chuck again. Perfect job for a scroll truck right here. All right, we're also going to be using my 20N Jacobs chuck. And what I'm going to use is this drill to spot it, to get it started. And then we'll use our 21/32 to drill it, and then we'll chamfer it, and then hopefully power tap it as well. Also going to use one of the new Eagles that I picked up while on my road trip. Fine tip. This is a number 33 Eagle, and it works great. So let's see how our alignment looks since I've aligned the headstock and the tailstock a little better. You see it pick up just a bit. Side to side looks great though. I'm just spotting it there. Swap it out for we're going to go straight in with our tap size. This is a brand new drill. I hadn't used it yet. Should have a nice factory grind on it. Slow it down. Got it in 370 RPM now. Drill didn't want to center up very good. Sure didn't. I'm going to use a center drill and see if I can improve that. Got it center drilled now. Kind of true that hole back up. New drill, but it's not ground very good. Probably cutting oversize. That's one of those zero flute welding type countersinks we're going to use. Just use it to chamfer it lightly. Probably about good right there. So my buddy Barry that I bought this chart from right here, this union chart, he had made a suggestion that I should make some video of actually how to use this for some of the guys that may not know. So this is my union twist drill chart that I already had, and we're about to do some 3/4 tin tapping. So on these charts there, see, this is a decimal chart on this side, decimal equivalent, and then this is going to be your tap chart for tap sizes. So what we want is 3/4 tin, that guy right there. And this is an interesting chart because it gives you 2 different drill sizes to use. It gives you the decimal equivalent size of the drill. And then this says probable hole size, which I find very cool because anytime you use a drill bit, it's always going to drill oversize. And then this is going to be your percentage of thread, this line right here. So that drill is going to give you about 80%, and then this drill here is going to give you approximately 68%. And what you're usually shooting for most threads is 70% of your thread. So we're going to use, let's see, where were we at? 21/32 is what we'll use right there. And I got my drill index down here. And we'll just find 21/32, which is that guy right there. And this is going to be our tap size for a 3/4 10. We're going to try my gun tap. This is a 3/4 10 gun tap. This is in an adapter that I had made. I believe I had to use this in the milling machine. I don't really remember where I had to use this, but it was probably for the mill. But since this is a 20-inch chuck, this will hold up to 1 inch, and this is a 1-inch shank. So we are going to try it in that right there, and we'll torque it down good. Get the two that I can reach right there, and let's go for it. I'm just going to go with 30 now. I'm sorry, that's 65. Let's slow it down. Wet the drill or the tap good. That should be pushing the chips forward. Keep it well oiled. We're still going. Just about. Looks like we got just enough. All right. Cool feature on the Victor, there's a reverse jog button down here. I can just hit it with my hand and reverse it out of there. So the tailstock is just floating, guys, for those that are wondering. It's just sliding along the ways there. The thread is what's pulling and pushing it. And then once you get out to the end, I put a little pressure on it and slide it on back by hand. Well, them threads look pretty good. I don't have my air on to blow it out, but it looks like it did a fine job. After doing another one, the center drill providing an actual pilot hole for the tap drill to follow is a much better than what I did the first time by just using this drill here, because the center point, because of the angle difference, this being a split point, it's got a different angle of the drill. The jobber drill just come in there, it was only touching on the chisel point, so there wasn't anything to support the drill to keep it centered. So I'm using a center drill like I usually do. Like that. Now this will allow it to stay centered as it's going in there. All right, we're going to tap one more. And by the way, Abby came in here to watch us tap a hole. You probably see her feet over here with her OSHA approved open toe flip-flops on. Our machinist taps a hole.
Extremely sexy.
Oh, almost got the tip stuck in there. All right. That's it. Reverse it out of there. Okay, we've got all 6 of the weld-in plugs finished. turn, drilled and tap, and that's what it looks like right there on this one. This is another one right here that will screw it down on there. Got a lot of thread engagement there, so it should provide a nice contact area. There's what the feet look like, so this is what will be sitting down. They all have this hex nut there so that we can kind of lock it in where we want to once we get it leveled. Yeah, there we go. Turning out pretty good, making some good headway on it. So I'll walk you over there to where the tube is, and we'll stick one in there so you can see what it's going to look like. And then from there, the next step is to go ahead and get all 6 of these welded in. All right, so there's our tubing, which I believe you've already seen. We got the seams ground, and that's what I was talking about, so it would clear this turn diameter there. And then it'll look like this once these are welded in there. Just like so. Figured I'd give you a shot of them standing up so you kind of look like, so you can see what they'll look like once they're there. And I'm looking forward to having this thing together to actually see what that's like. I've never used a table that has these rubber pads on the bottom like that to kind of isolate it. These are actually machinery mounts, anti-vibration machinery mounts is what they are. And whenever I seen Jack had those things and he didn't want a lot of money for me, I just thought, hey, let's go ahead and use those for the table. I think it's going to work out really good.